The notion that things that we touch with our hands, feel, are made of ideas or concepts actually is probably an older idea than we might have thought. And it's a difficult idea to really grasp or get a hold of. But let me try to explain it this way. When we began to look at small corners of space and little pieces of time, we began to see that the objects that we discovered in these regions of space and time weren't just persistently existing. They were kind of popping, like bubbles in bubble wrap. Pop, 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 on and off, on and off. And in order to explain that, we wondered what they were doing when they weren't appearing as pops. What were they before that? Then we did more refined experiments, and we found that we could take objects and let them interact and fly apart, and then measure something about one of the objects, and we'd find that the other object would also change at the same time that the first object was even looked at. In other words, if something popped over here, instantly the other one would pop, whereas if we hadn't popped this one would just pop randomly. So how could pop 1 be connected to pop 2 when they weren't separated? So this gradually led into some notions that there was an invisible connection between everything. Physicists give this a name. They call it entanglement. Or we now speak of it in terms of a state or an invisible state. We call it a state vector or a quantum wave function because it seems wavy. It seems spread out over space and time rather than concentrically localized in one place at one time. However, this wave function isn't just a wave of matter like an ocean wave or a sound wave or any kind of wave of matter. It's a wave of possibility. It's a kind of thought wave. And because it is a wave of thought or possibility or not matter, it's invisible to us. But we can't explain what we do see as matter in these small corners of space and time unless we picture that these matter particles somehow come out from or emerge from these thought wave patterns which are invisible to us.
Quantum mechanics is really the play and display of information, the play and display of potentiality, waves of information, waves of potential electron. And it's important, the word potential. This isn't the world of electrons, it's the world of potential electrons. But when you have to ask the question, waves of what, really? What is the field that is waving? Is it the ocean? No, it's a universal ocean, an ocean of pure potentiality, an ocean of abstract potential existence. We call it the unified field, or superstring field. And that's what we're made of.
Connectivity among all things is a basic constituent of the fabric of reality. It's very difficult to wrap your mind around that. But Erwin Schrödinger said, he's one of the founders of quantum mechanics, that entanglement, which is this idea of this connectivity, is not just a property of quantum mechanics, it's the property. It's the property of quantum mechanics that makes it very, very strange. And it doesn't seem to fit in with our ordinary world, our ordinary experience, but in fact, it actually does.
You want to shoot some hoops? Now you don't have to be like that. Come on and play. Look, he likes you. Don't you have time for a little one-on-one? How long has it been since you played? Come on, you got the ball. Take a shot. No, my lady, not from there. It's out of bounds. Gotta be on the court to be in play. Welcome to Duke Reginald's court of unending possibilities. sink the last one.
That hung.
It never touched you.
Right.
And it's not solid. This ball is mostly empty.
We were all taught in school that the world is made of stuff, of matter, of mass, of atoms. Atoms make up molecules, molecules make up materials, and everything is made of that. But atoms actually are mostly empty. For example, if this ball were the nucleus of an atom, a proton in a hydrogen atom, for example, then the electron circling this, which would describe the outer limits of that atom, would be out by that mountain over there, roughly 20 miles away. And everything in between is empty. In fact, the universe is mostly empty. However, when we go down in scale, in the emptiness, we eventually come to a level, the fundamental level of space-time geometry, the fine basement level of the universe, where there's information, there's a pattern. It's called the Planck scale, and it's the fabric of the universe. And at that level, there's information that's been there since the Big Bang. So most of the universe, even of matter, is actually empty.
Most people think that the vacuum is empty. But for internal consistency of quantum mechanics and relativity theory, there is required to be the equivalent of 10 to the 94 grams of mass energy, each gram being E equals mc squared kind of energy. Now that's a huge number, but what does it mean practically? Practically, if I can assume that the universe is flat, and more astronomical data is showing it's pretty darn flat. If I can assume that, then if I take the volume or take the vacuum within a single hydrogen atom, that's about 10 to the minus 23 cubic centimeters. If I take that amount of vacuum and I take the latent energy in that, there is 1 trillion times more energy there than in all of the mass of all of the stars and all of the planets out to 20 billion light years. That's big. That's big. And if consciousness allows you to control even a small fraction of that, creating a Big Bang is no problem.
Organizations like NASA, British Aerospace, are all trying to tap into this incredible, unimaginably large energy sea. And they feel if they can tap this, we can travel to different galaxies. So they understand that in empty space, there is this unbelievable energy.
When you begin to really grasp this, you begin to grasp the enormity of the energy that would be involved in going down this rabbit hole. What is available for us to use in the future to take us to the stars? The issue is we are perturbing this with consciousness. We are able to, with directed consciousness and intention, we are changing things at the vacuum level, which then allow us to access a new level of physics. So we can do that at that level, not so much at the atom molecule level. That's a secondary effect. So we're already doing it in essence. We're already getting into the rabbit hole by using intention.
We're really living in a thought universe, a conceptual universe. Quantum mechanics is just the play and display of potentiality.
If you put it that there is an intangible world that affects the tangible world of our experience, and if you then say that's what quantum mechanics says, and granted that's a fair way of trying to put into English something which is very, very difficult to grasp, but it then leads quite naturally to the conclusion that quantum mechanics says that there is a spiritual world that makes this choice, that there's another world that is intangible, that affects and influences the physical world. And really, while that statement might be true, quantum mechanics absolutely does not say that. That intangibility, however, is itself the bedrock of physical reality. It may be intangible, but it is, and we can't really say what it is or why it's there, but it is in fact the most fundamental feature of matter. So you could say, well, if it's a feature of matter, that's not intangible. Matter is the most tangible of things. So, I mean, these are word games. The fact of the matter is that the matter is not what we have long thought it to be. To the scientist, matter has always been thought of as sort of the ultimate in that which is static and predictable. And the more you understand the material aspect of something, the more perfectly predictable it is. What quantum mechanics illustrates is that that is simply not true.
The major basic idea that quantum physics implies, which makes us understand this or even think about this new paradigm, the thing which is that there's this underground, there's got to be a realm of existence which cannot be ever touched on or seen, which bubbles into the existence giving rise to our understanding of the world.
The tighter physics have tried to grasp onto physical reality, to understand what it's really made of. What are the core building blocks of life? At the basis of it all, life, the universe, slips through your fingers. And you come up with something that's increasingly abstract to come to the realm of pure abstraction. And that's what the unified field is. It's pure abstract potential, pure abstract being, pure abstract self-aware consciousness, which rises in waves of vibration to give rise to the particles, the people, everything we see in the vast universe.
What makes up things are not more things, but what makes up things are ideas, concepts, information.
And like I said, it never touches.
Another strange fact is that objects never really touch each other. When I dribble this ball, the atoms of the ball and the atoms of the ground never actually meet.
So nobody touches nothing. Come on, put your stuff down. Nobody's gonna take it. Like I said, this is my court. It's no problem. How long has it been?
I'll be 8.
The first inkling in physics that we got that time ain't what it seemed to be came with relativity. That was the first inkling, that time was not absolute, it was not the absolute ruler of the universe, that God Almighty did not say 1 second, 1 second, 1 second, 1 second, 1 meter, 1 meter, 1 meter. You're in a gravitational field. Your head is actually moving at a slightly faster rate than your feet.
The second law of thermodynamics says that things unwind and move forward, so that gives an arrow of time. But at the quantum world, in the micro world, the second law of thermodynamics doesn't seem to hold, and things can go backwards or be timeless.
The fundamental equations of motion that we have, both in classical mechanics and in quantum mechanics, have this property called time reversal symmetry. Okay? That is, there's a certain way in which they don't distinguish between the past and the future. Or to put it slightly differently, these equations entail that for any process that's possible, the same process happening backwards is possible. Now, when I say happening backwards, I don't mean going backwards in time. I mean, as time goes forward, the reverse sequence of things happens. Okay. The world isn't like that. There are all sorts of what people refer to as time asymmetries in the world. And people usually chop these asymmetries up into 3 different levels. Level 1, there are all sorts of ordinary physical processes, ice melting, smoke spreading out in a room, people getting wrinkly as they get old, so on and so forth, that we never see happening in reverse. 2, we have a very different kind of epistemic access to the past than we do to the future. That is, the ease with which we can know things about the past and the way in which we come to know things about the past and the detail with which we can know things about the past is utterly different than the ease and the access and the detail that we have to the future. 3, an asymmetry of influence. We have a very deep conviction that by acting now, we can affect the future, but not the past. Given the complete time symmetry of the fundamental equations of motion, all of these 3 asymmetries are extremely mysterious. And moreover, they're asymmetries that play an incredibly fundamental role in every second of our lives. That's been a puzzle hanging over physics for a long time. Where does this asymmetry come from, if not the equations of motion? The equations of motion are supposed to be the whole story about how the world works. But in that story, these asymmetries don't show up at all. And yet, these asymmetries are profound, ubiquitous, inescapable features of every second of our lives in the world.
One of the most unpalatable ideas still, in spite of the fact that quantum physics has been around a long time, is the possibility or the notion that the future can have a causative effect on the present. We believe that the past can have a causative effect on the present. I hold the ball, I drop it, it falls. Cause, effect when it hits the ground. But could the ground be the cause of my dropping the ball in the first place?
It's only in conscious experience that it seems that we move forward in time. In quantum theory, you can also go backwards in time, and there's some suggestion that processes in the brain related to consciousness project backwards in time. For example, in the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet, did some very famous experiments. What Libet did was to study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex. Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When he stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay. After sorting through all the data and repeating this over and over, Libet came to the conclusion that somehow the brain was projecting information backwards in time, so that it did take a finite amount of time to get to the sensory cortex, but the brain projected it backwards in time so that the conscious perception was that the stimulus was felt when the pinch actually occurred.
There have been some studies which have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain in certain nerve cells of the brain, even before they become consciously aware of what they're trying to do.
In baseball, a scientist showed that if you study how a batter can hit a pitch coming at 100 miles an hour, considering the recognition, the visual processing, the motor response, the reflexes, synaptic delays, it's impossible. That was his conclusion. How could it be accomplished? Well, one possibility is that as the batter is standing there, the ball comes across the plate and the batter sees where the ball is and recognizes it and decides where to swing by the time the ball is already in the catcher's mitt. But the information is projected backwards in time so that he or she swings at the previous time when the ball is just coming across the plate. This could be happening all the time in our normal everyday consciousness. And there's some other experiments that have shown this. Dick Bierman and Dean Radin have done some experiments where a subject sits at a computer screen and watches a series of images which may be somewhat bland or may have highly emotional content, and they just study their galvanic skin response as a means of emotion. And they vary the timing of when the picture is going to occur, so the subject doesn't know exactly when it's going to occur. And what they find is that, not surprisingly, the emotional pictures give a much greater response, but that both the emotional and the unemotional responses show up a half a second to 2 seconds before the stimulus actually occurs on the screen. And a fellow named Chester Wiley replicated this not only in humans but in worms. So this may be possibly a very widespread phenomenon of backwards projection in time. The only explanation is through quantum physics.
Pat Price he was a fantastic remote viewer, and he was supposed to draw where his traveler was going as usual. And he drew 2 tanks and a swimming pool. And when the investigators looked at it, the scientists said, Pat must have just got it wrong this time, because he was right about the swimming pool. They had sent their traveling partner to the municipal swimming pool in Palo Alto. And they said, Pat just got it wrong this time. Months later, one of the scientists received something from the Palo Alto Chamber of Commerce, and it had images of the municipal swimming pool 50 years earlier. And what they saw was the swimming pool, but 2 tanks exactly where Pat had drawn them. And so what Pat's mind had done was not to see what the swimming pool was in present time. He saw it back as it was 50 years ago.
I know it seems to me that I often do things and then decide a fraction of a second later what to do, but I've already done them.
We're beginning to see that even time itself is not sacrosanct. We're allowed now to get into it in a different way. David Deutsch, Oxford physics professor, was, I think, one of the prime inventors of quantum computation, the quantum computer, and he is very much into parallel universes and time travel, and says all the paradoxes now of time travel. You can go backwards in time and knock off your father and mother before they have you and come back, and you're still alive and no paradox. And even to explain that is difficult to do, but nevertheless, put them in a parallel universe and it's no problem. So these are the kinds of things we're doing in physics right now. We're rethinking time, and it may very well be that the next phase of time travel in a physical device may be in the next 50 to 100 years from now.
Science suggests to us that parallel universes are living simultaneously, that we're living 100,000 lives, or 5 lives, however much you can handle, simultaneously, and that all the things that we do are at work right now.
I believe.
You can always go back in time. What's the matter? Remember, it's empty.
How do you know this yet?
I read Dr. Quantum comics.